The sine function is not too bad to graph. The main thing we have to remember is that we're transferring the unit circle into an x and y coordinate. Now, the unit circle has an x and y coordinate, but we're actually measuring around the circle. And as we learned in the project that we currently did, is that we separated, we measured the unit circle and with the string, and then we spread it out for it to become the positive x-axis. And since the unit circle is measured in angles, we figured that the x-axis is now equivalent to theta. So I know that that's going to be theta because that is going to be exactly similar to the x-axis and the tick marks that we put around the unit circle, the measurements. So the way we're going to split this up is actually using quadrantal angles. And the quadrantal angles are the 0 degrees, the 90 degrees, the 180 degrees, and the 270, and back to 360. They're called quadrantal angles because they fall on the x and y axes. So if I look at this, I'm going to split that into 4 equal parts. And so the first one here is going to be 0 degrees. It's going to be then 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. So that's how we're going to split it up. And if I do that on this part of it, that's from the unit circle going counterclockwise. So these are positive x values. So therefore this is positive because we're going counterclockwise in the unit circle. If we're going clockwise, that means if we're going this way, that means that we are going to be going in the negative direction, and therefore that's going negative in this direction. So I am going to put in 4 tick marks on the side as well, and this one here now is going to be negative 90, negative 180, negative 270, and negative 360. So those are the ones on there. So this one here is going counterclockwise. So when I graph it, this is going to be counterclockwise, and this one here is going clockwise. So that's the directions in which we're going, positive and negative angles. Okay, so the unit circle is also split into those parts on there. The ones that we really know is that this here is going to be 1, 0 because that's a radius of 1. So from the origin to this point is going to be 1, 0. From the origin to this point is going to be 0, 1. And from the origin to this point right there is going to be the same as 0 and 360. It's going to be 1, 0, but it's in the negative direction. So that's going to be negative. And this one here is going to be the same thing as the 90. Except for because it's in the negative y values, I am going to have that to be a negative 1. So when you graph it over here, while this angle, the x-axis represents the angles around the unit circle, the y-axis is going to represent the trig ratios. So these are the trig ratios, the 1/2, the square root of 3 over 2, the square root of 2 over 2. That's what it's going to represent. So when we actually graph it, the value that we're going to go is going to start at, if I am doing sine, so I'm only looking at the y values of these values, because remember that it's going to be the y values is going to be equivalent to the sine of x or the sine of theta. And so therefore it's going to be 0, 1, 0, negative 1. So it's going from 0 to 1, back to 0, back to negative 1. So we're going to start here at 0. And then we're going to go up to 1, and I'm just going to make this one here to be 1. So I'm going up to 1 at 90 degrees, and then at 180, I'm going back to 0, and then at 270, I'm going down to negative 1, and I'm going to put that about right there, negative 1. That's going to go down to this value right there, negative 1. I don't know where this line came from. And so that one's negative 1. And so then it's going to be up here to 0 at 360 again. I'm back to 0. So it's going to look like if we graph it, it's going to go from here down and then back up. And then it's going to repeat again. And so then we do this on the other side, and we're going to go, if I go backwards, I'm going to start at 0 and then go down to negative 1 and then go up to 0 and then go back to 1 and then go back to 0. And so this here is what the sine curve is going to look like, and it's going to be repeat over and over again. It's just going to keep going up and down. And this is what we call a sinusoidal. It's going to go up and down, up and down, up and down. And so that is what the sine curve is going to look like. And you could do that using your left-hand rule and then working through it. Now, because we know that we know that sine is related to the reciprocal, is going to be cosecant. We could also graph cosecant. Now, cosecant is something that is going to be the reciprocal. So the only problem that we see with the reciprocal is 1 and -1 are not a problem, because the reciprocal of 1 is 1 and the reciprocal of -1 is -1. But the reciprocal of 0, that means we're going to have 1, and so the reciprocal is going to be um, the reciprocal of 0 over 1 is going to be 1 over 0. You can never divide by 0. Anytime you have 0 in the denominator, it will always equal a vertical asymptote. So wherever sine is 0, so this is where sine is 0. That means that the cosecant of sine is going to be a vertical asymptote. So when I'm looking at this, see how sine is 0 here? That means that the cosecant is going to be a vertical asymptote. And then here again, sine is 0 at 180. So that means I am going to have another vertical asymptote. And sine is 0 at 360. And I know by looking at the graph or the unit circle that sine is 0 at these values, because these are the x-intercepts. That means that the y values are always going to be 0. And then sine is 0 here as well here. And so those are the asymptotes. So what happens with the reciprocal? We flip it. So that means that we're going to flip this it looks like a parabola going down. It's concave down. So this one here is now going to be concave up, and it's going to approach these asymptotes. And then here, these are the asymptotes as well. So then, I don't know why it does that. And so we know that that is going to be 0 there as well. And so then now it's going to flip and go this way. And then here is also going to happen. It's going to flip this way and flip that way. And this one is going to flip that way. So anytime that you have the reciprocal, I could graph the sine, and then the cosecant will follow by just flipping everything on there. So you could flip two trig functions at once. Sine is the easier one to graph, and then you could just flip the area of the cosecant, and then that gives you the graph of the cosecant.